Oh yes, everyone. Today we are going for another field trip. There are a lot of places we are going to pay for a visit today. We need to go to the Emera, which is one of the biggest utility company here, to take a look at their solar panel and test their battery pack. Then we will go to IKEA. I have a video on IKEA before, but we are planning to make another one. Finally, we are going to see some 1.5 gigawatts G wind turbines out of the city. Yes, let's go.
I'm Josh Islip. I work for Emera Inc. I was the project manager for this build. I actually had a few co-op students throughout my term. I think one of them is in the class today. Chris, are you here? There you are. And so this project was about 2 years, 3 years with design. It houses all of Emera Inc.'s. There's about 400 people in here today. And people keep on moving in, so another 200 are moving in 2 months from now. Today we're going to show you the Tesla Power Pack. Martin and your professor Luke will show a lot more detail than I can. But our corporate communications department's here. She's going to take a couple photos, and she might ask for a couple quotes from you guys if you're willing. That's it. Super, easy.
And Martin from Emera as well. Would you introduce yourself and tell them what we're going to see?
Sure. So Martin Rovers, and worked with Josh on this project. My role with Emera has been to support our utilities. As you know, Emera is an energy company that owns multiple different electrical and natural gas utilities across North America. And so we work with each of them in developing how they're going to respond to what we see as a shifting energy industry. And that's really different market by market. But one of the common things that we're finding is that as we make a switch over to renewable electricity, is that battery storage is a big part of it, or other types of storage technologies. And so in each of our markets, whether it's in the Caribbean or in Florida or here in Nova Scotia, we've been looking to build some experience with a lot of the new electrical storage systems that are getting developed by a lot of the larger companies. And this project is no exception. So in Barbados, in Tampa, and in Nova Scotia, we're going to Elmsdale?
No, we're not going to
Elmsdale. But in places like Elmsdale, we're doing large grid-scale batteries that go on the system. But we also know that there's smaller batteries that customers are either putting in their house or putting in their commercial or industrial facility. And so this project here is our work to build understanding on how customers are going to use batteries to benefit their own operations and how they can also use it to potentially benefit all customers. And so this is an example of a solar storage system that customers are adopting and putting in their facilities. It's one of the first in Nova Scotia, and so it consists of a Tesla Power Pack, which is lithium-ion batteries, about 100 kilowatt, 200 kilowatt hours, and then a 50 kilowatt AC, 40 kilowatt DC solar system on the roof.
Is that the sound of shutdown?
That's the sound of shutdown. For safety, we'll shut it off.
Yep.
Okay, all right. Do you want to say about what all the parts are, Martin?
No, you walk them through it. You know the,
okay.
you know the
So, ladies and gentlemen, you are looking at a Tesla Power Pack system. This cabinet right here over here on the left is the lithium-ion batteries. And the cabinet on the right over here is an inverter system, a bidirectional, we'd call it a converter system. The electrical from the building is coming underneath here in buried conduit and will be popping up inside right here. You see the 3 phases coming up plus some neutral right there. So that's 3-phase electricity, pretty heavy cabling. It goes into these converter racks. There's 2 of them right here. Each one's going to be rated 50 kilowatts, I think. And so you can see that they have some liquid cooling system going on right over here. There's grounding. That liquid cooling system goes up into the top where you've got a fan system set out right there that blows air over them to keep them chill. There's control and safety hardware here on the left. Inside or next to these cabinets, the DC cabling goes down and goes in this above ground conduit right here over to the actual battery system, and then goes up inside. Inside this battery system, and we can't get this open right now, but there are these pods that are located in here. Each one's about that big and consists of two Tesla battery modules to equal 50 volts. The lithium ion batteries inside there, each one's about the size of my thumb, each cell. And they're grouped into packaged groupings of cells and then multiples of those in series to create 25 volts, and then the second group makes it 50 volts. There will be several stacks of them right here that go in, and they'll all be interconnected. It's a very special system in that each pod has a DC-DC, which switches the 50 volts up to about 800 volts DC, and then goes on a common bus bar that traverses back over the inverter section. If you look right here, you'll see there's a cooling system right here in the door. These are liquid cooled batteries. So there's a flowing glycol water loop that passes through each cell group to keep them at optimal temperatures. And so in certain circumstances, you'll heat them up. And in other circumstances, you'll cool them down depending on the use profile. That
Like today, it will be heating up somehow?
Well, if you wanted to operate them hard today, you would absolutely be heating them up. And then there's usually a refrigerant system based cooling right here on the front so that you could put these batteries in a very hot environment, call it 40 degrees, 45 degrees Celsius in the desert, and still keep them cool. Their nominal operating temperature range is about from 10 to 40 degrees Celsius. They'll go a little bit outside of those realms, but that's the pretty typical operations that are there. This system's set up in that you can see the DC conduit coming across the bottom right there, that if you wanted to put another power pack, you could set it right in here to increase the energy storage capacity of the system and just interconnect that in. And you can see the same thing, that this is a modular converter right here, and that you could take these cover plates out and you could slide more inverter decks in or converter decks in if you wanted to increase the power of it.
It's just like putting more graphics card in your desktop computer, isn't it?
Very similar. The Tesla is the most granular system that is available on the market today. Other systems are larger where a single component does more. They chose to go very granular with these so-called pods that are in here, and the DC-DC converters and the expandability above ground without the conduit underneath it. Yeah. Okay. Tell us about the size and what it's for, what you use it for.
Yep, so the inverter is 100 kilowatts, and the battery is 200 kilowatt hours worth. If you think about what that means, your average house typically draws about 2 kilowatts of load. So you could, this inverter would serve about 50 homes. But in terms of a commercial building of this size, the peak load here, as you'll see when we do the live display, is about 500 to 600 kilowatt peak, averaging about maybe 300 to 400 kilowatts. So this 100 kilowatt system certainly, for example, can't island the building. That's not its objective. It's not here to serve as a reliability asset where sometimes people put batteries in their homes. That's one of the most common uses there, is when the power goes out, the battery can serve their home. Here, in most commercial settings, the objective of the battery is to reduce their electricity bill. And for commercial buildings, we have two types of charges. At your home, we just charge you based on how much electricity you use, how many kilowatt hours. For commercial customers, we charge them based on how much electricity they use, but we also charge them based on the size of their peak demand. Because the higher their peak demand, the more infrastructure we need to build on the system. So if one customer has an average consumption of 300 kilowatts, but another goes up and down all the time rather than smooth, we're going to charge that person who goes up and down more because we're going to have to build more capacity. And so they can use this battery to smooth out their load. When their demand is high, they turn the battery on. When it's low, they turn the battery off and charge it. And so it can smooth their profile and reduce demand charges. And that's really what we're demonstrating with this battery here. And you'll see that when we go upstairs and actually demonstrate. You can see how the battery's been getting automatically dispatched over the past week or so.
Great. Questions?
Yes. You said this is like 100 kilowatts because of 2 converters. Then is it possible you add more converters but still use one single battery pack to increase the output? Or is that a limitation?
There's a limitation on the cells. Yeah.
So what's the limitations on the cells themselves?
Well, you probably know this better than I do. I know the Tesla, we've seen 2-hour systems. Do the cells actually have capacity to provide more amps? I don't know.
I think they can. I think they limit it to 2 hours right now just because of the cooling system that's on board and the control strategies that are applied.
Yeah.
Right.
Are these systems always placed outside?
You can put them inside, and almost always are put outside. There's a lot of fire code in New York's a good example where they want to put them inside, and they're working on making the changes to both the battery design and the fire code to allow things like that. But they have the capability. And power packs, the smaller version, but uses the exact same batteries, very frequently go inside customer homes.
Power walls.
Power walls, sorry.
This one had to be outside just because they're working on the fire code applications.
How long has the system been installed for?
Put it in
The fall or the late summer
late
of
summer.
last year.
Yeah.
Do you have any future plans? I think the ground here looks quite limited. Is there any future plans like to expand this one?
Well, as Dr. Swan said, there's room for more battery capacity in here if we wanted. But no, right now, the primary objective of this is a demonstration project. The business case right now for these batteries in Nova Scotia don't hold. You're not going to see every commercial customer put them in tomorrow just because demand charges in Nova Scotia are low, because generally our system is not growing in capacity. Typically demand charges are highest in markets like New York, Massachusetts, where the demand is constantly growing, and so the batteries provide an alternative, for example, to building a new gas plant. But in markets like Nova Scotia where demand is not growing, demand charges tend to be lower, and so the business case is not as strong for putting these systems in. But we know these battery costs are going to go down, and they are going to start getting adopted in Nova Scotia, and so we need to start making sure we have the electrical code, the fire safety code, the experience as a utility, and supporting our customers as they look to adopt them.
How long do the batteries?
Could easily fit in your basement. You have far lower cooler and heating costs. So is it mostly the safety issue that makes it outside?
Yeah, I think it's the fire code. Yeah. Sorry, I'm just seeing if I can get the key for.
Say again?
How long do the batteries last for? How many years?
Those would be designed to last a gross about 20 years. They'll degrade slowly over time. And so being a granular design like that, you can add on, it's called battery augmentation, to maintain the capacity at the original size. Or you just let them degrade and you have, say, 70 or 80% of the performance at a later point in time. And we see this in photovoltaics. We're going to go upstairs and see that in just a moment. And they degrade in time as well. And it causes less performance, but you just budget that into your design and the performance evaluation when you're scoping the project.
Since we are talking about how long it can last, what's the warranty Tesla provided on this one?
I think these ones are 5 years. We have a degradation curve. Like the warranty is not 100% capacity after 5 years. There's a degradation curve that they provide to us, and it's understood that it will be at least above that degradation curve.
Great.
They come once a year and they do preventive maintenance, test everything, and then they provide a report.
Yeah, and you can get a capacity guarantee contract with a lot of battery companies like LG, Samsung, Tesla, where they say we guarantee it will stay at 100% capacity. And all that means is, one, they'll start by oversizing it a bit, and then after 5 years they'll come and put some extra batteries in, but they'll take care of that for you.
Yeah, for this one's communication system, is it like a hardwired through Ethernet to the building or through wireless?
It is.
This is
It's
sad.
hardwired, and it also has a GSM module where it can transmit data
Great.
back to Tesla.
You can see the controller over here in this box.
battery cycle? Does it happen every day or weekly or?
When I'll show you when we go up there. We'll take a live look at the control system at the SCADA.
Super.
Yeah.
Why don't we head up?
Already have one of the questions. Why I feel also solar panels are put on these these kind of stones instead of just a big flat concrete slab.
Well, it's because this is a different type of roof. It's called an upside down roof. So it has a membrane that's up top. And if you drop something, you would poke a hole in the membrane and make the roof leak. So this holds down the membrane and protects it as well. And protects it from the guys that were up here installing. Yep.
There you go.
So, and actually these are the 400 watt ones. One thing you'll notice about solar panels is they've been getting steadily bigger over the past 10, 15, 20 years as solar has really taken off. And these are I believe these are our LG solar panels. And we actually got the whole system installed here by a company called Solar Global Solutions. Does anyone know Solar Global Solutions?
It's actually just I think a 5 minutes drive from where I live.
Yeah, that's right. So they're a great Nova Scotian company, one of the first ones getting involved in solar work. And we brought them in to do the job here. They did a fantastic bit of work. You'll notice the panels themselves. One of the biggest challenges with putting solar systems on roofs is actually the load that they can put on the roof, because a lot of these commercial buildings, the roof is not designed to take additional load. They figure out what the load is going to need to take to hold up the roof, and that's what they build the capacity to. And then when you go and say, okay, now I want to put some solar panels on there, it actually can put some challenges in. So what we actually had to do, rather than ballasting down these panels, which you'll see done on a lot of facilities, that takes more load. So these are all anchored directly into the roof, which has reduced the amount of ballast that we need to put in and actually allowed us to meet the roofing requirements on this building.
And the low angle. If we would have had them tilted up like this, then you have the wind pushing down, and it's just not made for that type of load.
Yeah, I think it's like 10 degrees, not even. Yeah, not even. Ideally, they'd be higher.
Ideally, you want to use the angle of the solar panels to match your latitude, right?
As the first approximate, that's a good place to start, yeah. And so what you're seeing here is about 25 kilowatts AC of panels with a 20 kW inverter right there. And on the other side, it's the exact same system. And that's one thing that you'll notice is that the ratio of AC to DC has been declining over a lot of solar builds. Sorry, the ratio has been increasing. And the reason is the panels are getting cheaper and cheaper. And so often you can oversize the amount of panels that you put on an inverter. And what that means is sometimes you'll throw away excess solar energy, but the panels are so cheap that's still the most cost-effective solution in the system. It's particularly true in a lot of the builds in the south. But often on builds this size too, it's just how much room do you have on your roof to put panels, and what's the best cost inverter, and what's its size. So when you're doing a system as relatively small as this, that's also going to drive your AC-DC ratio. But you'll see how we're already cutting off solar, and it's very much a cold March when we look at the live display.
And I saw a wind cup on the top.
All right, the hybrid system, solar wind.
No, that's small wind cup.
It's just an anemometer just for data.
Yeah.
What do you guys do for snow? Like in winter, they're going to cover most of the panels. Do you wipe them off? You just
No, it's not cost effective. The amount of kWhs you lose, they're not worth enough to send a person up here.
If you put your panel more vertically, then I think it can partially solve the problem. The snow will slip, but you cannot. And two questions. The first one is, will you encounter the problem of bird poop during bird seasons? Like, I just saw a seagull fly by, so will you face
We have an
bird?
agreement that they will not.
So are you going to like clean it for several period of time?
Yep, same idea as Tesla. Solar Global Solutions will come in. I think it's semi-annually, and they'll
Yep.
clean and inspect and
Great.
test.
And what's the rated efficiency for these panels? I know they are constantly improving over time, but
I don't know, probably 16, 17%.
Yeah, that'd be a test element right there. Absolutely. So that's getting a voltage output as a function of sunlight. This is the collector wires right here for the DC. And this is
But
the
this
tech
holds them
cable
down
that's
here.
the AC coming out, which goes across the roof and then penetrates down in and goes into the penthouse. You got a big disconnect switch right down here. You got some grounding that goes into it, some control cabling that's right here, which will reply back and keep the SCADA system up.
This building was built in the 70s. There's not a lot of rebar in it. We had a lot of structural concerns, not just for this, but the other thing, even cutting holes for slabs for the conduit going through, always had to be x-rayed. If you hit a piece of rebar, we had to stop. Normally you just go right through it. So yeah, just it's the age of the building.
well, it's like renovating an old building to fit it with modern technology. in it.
That's right.
Well, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You got 16 times 4. So you're producing about 16,000 watts right now. 16 divide, 4 divide.
Right now it's
So
19.
these panels are putting out about 250 watts a piece right now. Because the sun's at an angle, you can see the incidence angle is not perfectly normal to them at the moment. Plus, we're standing in front of a whole bunch of stuff. If we get out of the way, you'll probably see the number go up almost
Yes.
immediately.
Right now it's 19.5 kilowatts. So 19.6, 19.7.
So now we got a 20. I did my calculation based on 16,000.
That's fine.
We actually have heat pumps downstairs in the basement, and we take salt water from the ocean, put it through a heat exchanger. It goes to the either heating or cooling side of the heat pumps. There's about 12 of them in parallel, and then from there it gets heated up, sent up here, and it warms and cools the air, and then it distributes throughout the building.
Awesome.
Yeah.
Plenty pumps as well, I see.
Yeah, lots of pumps going to different systems, and then over here are actually the boilers. So a day like today when the sun's shining, even though it's really cold, the building still warms up.
Nice.
But if the sun wasn't shining, the heat pumps still work, but the boilers top it up, get it to the right temperature.
Emera showed us the real-time data acquisition and management system. This webpage is provided by Tesla. Yeah, you need to become a customer to be able to use it. It means you need to pay Tesla more money. The graph on the left side shows the harmony working between solar, battery, grid, and the building. The energy flow directions is so clear. As the system is used for peak shaving, that means they will discharge the battery to power the building when demand is over the monthly set limit, while charge them when the building demand is low. Overall, the power pack experienced a full cycle every month. Although they said it is to reduce battery degradation, we feel they should definitely cycle more to get more of their return as soon as possible. A fun thing is that the battery system would learn about the building over time. Well, it is Tesla with Elon Musk. It is just normal that the system is smarter than my supervisor. Okay, we are going to IKEA. I have been there once, but still be interested in that.
Basically the most important people in the world.
Let's go take a look.
I really like